Section 13.3 talks about inverse Laplace transforms for partial fractions. So, kind of what we did in the previous section when we did the inverse. The catch is, I'm going to try and apply the Laplace inverse. And if you recall, when we look at this table, the inverse is going back. So, given the right, you're trying to figure out what did you integrate to get that right side. And this is provided. Make sure you have a copy of it available next to you as you take the exam, the next exam and the final. So, if I take the partial fraction as is, I'll notice there's nothing about multiplied. So, denominator being factored, s maybe, s squared times yes, but nothing else. A perfect square, no problem. But say s minus a times s plus b, nothing like that. So, what I have to do, I have to figure out the partial fraction decomposition. If you recall, we're going to call this a over s minus 1 plus b over s plus 2 and figure out what a and b is, just like we did with partial fraction decomposition when we integrated. And if you work it out, that's what you get. And that would be n. So f of t would be what? And I'm trying to eyeball, what does this look like? Well, this looks like a linear term in the denominator. To me, that looks like 4. S minus a, e to the opposite of that a. So, s minus 1, the 2/3 is a constant. E to the 1t plus 1/3. E, the opposite of that is negative 2t. And there it is. That's all you have to do. Now, what's the catch? You have to tell me what number did you use. You used number 4, so you have to tell me either you put it right there or you put it on top of the equal. Either or will do, no problem. But I need to see what you're doing. When I get to this problem, I'm going to ask you to find the inverse Laplace transform on this. Well, you can't do it as is because the table doesn't have anything like that. So what you do, you figure out the partial fraction decomposition. And there it is. And I could tell this is f of t equal, and that's 2/5. Well, nothing changed. A positive, the opposite of that, right? That's what the table says. Minus 1/5 e to the negative 3t. So in my examples, I'm touching on every combination you will ever come across on the homework or on the test. Make sure that you finish this and you understand it. And whatever questions you have, bring it into our class discussion, and we could clarify this and get it out of the way. I have another one. This has 3. Well, it doesn't matter how many it has because I did partial fraction decomposition on multiple of those. That's going to be my f of t because I'm working backwards. This is 1/4, 1 over s. So this I know is minus 7 over 12 e to the negative 4t by 4. Oh, I didn't label that here, did I? Look at that. I would have been nailed on a test. And I know this is a 1/3 e to the negative t also by 4. But what is this deal of 1 over s? 1 over s, I notice that's number 1. 1 over s is really just 1. So I must have applied the Laplace on 1. So negative 1/4, and this is by 1, I believe. Is that the number? And there it is. And that's pretty much all you have to do. Make sure you know how to use that table, and make sure you number everything accordingly on your exam so you wouldn't lose any credit. Here, the same deal. I look at this. I'm going to ask for the Laplace inverse. What did you apply Laplace on to get that? You figure out the partial fraction decomposition. And this is negative. I know already this is e to the t by 4. But this, 1 over s minus 1 quantity squared. Well, I'm trying to eyeball where that happens. Okay, I'm noticing right there. Again, remember, there's only one of those. So I'm looking at 1 over s minus 1 squared. So s minus 1 squared, if I look on the denominator, s minus 1 squared, that's really 1 plus 1. So n equal 1. So I'm going to go back. It's going to be t to the So if I write this as sort of as 1 factorial over s minus 1, you don't have to do this part, I'm just showing you that for your notes. N equal 1. And it's matching. So it looks like it's going to be t to the 1 e to the at. And what's a in that case? It's a t. And there it is. And this is by 9. Okay, and the same deal. We look at the next problem. Actually, I wanted it to be just like that. That's fine. I'll apply the Laplace inverse transform on this to figure out where I got this from, but I don't have to do that. I figure out the partial fraction. Now, the partial fraction decomposition is going to take some time. You know that. So this is e to the negative 2t. I'm becoming really comfortable with that. But this, 2 over, and again, I'm playing all the possible combinations we can come across, and that's going to be 2, and we just did that. Isn't that t, e to the t? This is by 9. I'm looking at this. There it is. And that's all I have to do. And how about this problem? Well, same deal. Apply the Laplace inverse transform on this. And this is going to be f of t equaling, well, I know the drill on the first two. But this, I'm looking at, it's not a plus, it's a minus. I'm looking at s over, and I know this is by 4, this is by 4, s over s squared plus 1. S over s squared plus 1. S over s squared plus 1. I'm looking at number 6. S over s squared plus 1. 1 squared is 1, so a is 1. So it's the cosine of 1t. And there it is. Continuing right on, so part G, apply the inverse Laplace transform on this. Here, I'm going to have to figure out that this is s squared plus 2s. I need to take half of the middle number, which is 2, and square it, which is 1, and square it. This becomes s plus 1 squared plus 4. And there it is. So if I apply the Laplace inverse transform on this, again, this will take some time. It's not as simple as it looks. It's as simple once you get it into that format. I know that the right piece is e to the negative t by 4. This is becoming a habit. But this piece, I'm trying to match what this piece look like. There's a negative up front. I'll put a negative. And let me glance at, I'm looking at s over. So if I look at s over, I notice if there's a shift on the bottom, I need a shift at the top if there's an s. If there isn't, that's fine. But since there is an s, I'm looking there, I need this to match. Well, I could do that one way. I could say, look, I'm going to add a 1 and subtract a 1. And basically what I'm doing now, I'm really splitting this. So I know that's what the answer is, but still, I'm looking at this and I'm saying that is negative s plus 1 over s plus 1 squared plus 4. My negative times a negative is a positive 1 over s plus 1 squared plus 4 plus 1 over s plus 2. And if I'm applying the inverse Laplace transform on that, this piece I already got. I have this piece. Now this piece matches 6. I need to find a, so by 6, I know what this piece will equal, s plus 1. So the shift is actually s plus is a negative 1. So it's e to the negative t. And there's a cosine. What do you square to get a 4? Again, what do you square to get a 4? You square a 2. That's the angle, or the argument, whatever you want to call it. Now, when I look at this piece seems to match 5. Okay. And if I look at 5 clearly, I'll notice that the top, there's a small switch to the top. If I look at this one that doesn't have an s, well, s minus 1, I see that a is right there, e to the a. S minus 1, that means e to the negative t as well. The cosine, but it's not matching identically, because here, what do you square to get a 4? A 2, but they need the 2 there. So they say, what do you square to get a 4? A 2. They need a 2 there. Well, you could attach a 2 there as long as you divide by it algebraically. So this part matches, and that is not the cosine, you guys, the sine of 2t. And an extra 1/2. And that is number 5, right? Yep. Nope, not number 5. Oh, crap. I'm sorry. That's 7 and 8. 7 and 8. Look at that. I would have lost almost all credit on this problem. And Cassie probably would have called me in for a Zoom meeting just to see how did I get these answers by quoting the wrong formulas. And how about the last problem? Well, I glanced at this problem and I noticed that partial fraction decomposition for this is right there. And I noticed s squared plus 1 on the bottom and an s and a number. S squared plus 1 on the bottom. That matches 5 and 6. But one of them have an s, one of them doesn't. So what I need to do, I need to split this. That's negative 1 over s minus 2. That's easy. This is twice s over s squared plus 1 minus 1 over s squared plus 1. And now if I apply the inverse Laplace transform, so that would be f of t equaling, well, this piece I know, again, e to the 2t, that is by 4, done deal. Twice, let's see this one, s over s squared plus 1, s over s squared plus 1, so a is 1, it's a cosine of 1t. And what is that? Cosine of what? That's 6. Plus, and if I apply the Laplace on this, a number over, so those have to match. In this case, they do match, right? S squared plus 1 squared, so a is 1, the sine of 1t. And that is 5. And that would be my final answer. So I need to be able to get the partial fraction correctly, and I need to be able to quote those correctly. And that's pretty much it. I just want to check on one thing.